SQL Server supports three kinds of user-defined functions, each with its own specific features and benefits. Scalar functions are what most developers think of as user-defined functions, because they're most like the functions available in other programming languages and the built-in transact SQL functions. A scalar function can take parameters, contain complex processing, and return a single value of almost any SQL data type. Then there are inline table-valued functions. These are similar to views in that they each consist of a single select statement and each returns a table object, basically a set of results. But inline table-valued functions can take parameters, whereas views can't. Like views, you can use inline table-valued functions in statements that update, insert, or delete data, and you can join to them. An inline table-value function is essentially a view with parameters. And then there are multi-statement table-valued functions. These are similar to stored procedures, but they return an in-memory table object, which is a set of rows and columns that you can select from, instead of a static result set. This makes them a powerful view-stored procedure hybrid, because you can perform complex processing in them, as in a stored procedure, and select data from them as in a view. But the tables that these functions return are not updatable. Now, another way to categorize these different kinds of functions is as scalar and table-valued, which is based on the type of data that each returns. With that categorization, there are then two types of table-valued functions. So it just kind of depends on how you want to think about user-defined functions. User-defined functions are not allowed to have side effects, which is a bit of a limitation on their use. This means that they are not allowed to make any lasting changes in the database, such as to make changes to data or to alter the schema of any object. But there are more subtle actions that cause changes and therefore are not allowed in UDFs. For example, the rand function, one of the built-in transact SQL functions, generates random numbers. And as it does so, between times that you invoke the rand function, it retains state information about the last random number that it generated, because it uses that as the basis for the next random number. So that changes the state of the function and therefore requires SQL Server to store that state somewhere. So you can't use the rand function within a user-defined function. User-defined functions combine some of the best elements of stored procedures and views. Many of the tasks that you previously performed by using views and stored procedures, you can now handle better with UDFs. You can invoke these functions from views, stored procedures, and other user-defined functions from within batches and scripts, as well as from external applications. So they're very versatile in how you use these functions. SQL Server 2000 didn't permit non-deterministic functions in the body of a user-defined function. A deterministic function, like len, always returns the same result anytime it's called with the same argument values. On the other hand, a non-deterministic function, like getDate, always returns a different value on each invocation, because getDate is returning the date and the time, including the milliseconds, and so every time you invoke it, the value returned is going to be a little bit different. Okay? So that used to be a big limitation on user-defined functions. Fortunately, in SQL Server 2005 and later, things have loosened up a fair amount. So you can use some non-deterministic functions like getDate. Those kinds of functions are now permissible within user-defined functions. But just be aware, if you use any built-in functions within your function, your custom function, then you may get an error message saying that you can't do that because that particular non-deterministic function is not allowed. So that's what's going on. I also want to mention that you can create each type of user-defined function in SQL CLR code, that's code written using the .NET framework, as well as Transact SQL. For the most part, Transact SQL is recommended for functions that rely on set-related data manipulation, like select statements and so forth. And then SQL CLR functions are recommended for functions that require intensive computations or string manipulations. neither of which T-SQL is very well suited for. In some cases, the .NET framework contains base classes that supply rich functionality that would be very difficult to duplicate in Transact SQL. And the quintessential example of that is string processing, particularly doing things like with the regEx class to use regular expressions. There's some basic support for regular expressions in SQL Server, but it's not really a strong point of Transact SQL. But if your functions involve fairly straightforward data manipulation, Transact SQL is the best choice. And my focus here in this part of the course is on Transact SQL UDFs. All right, so let's start talking about these individual types of functions. And the first one I want to cover is scalar functions. Scalar functions are like the functions that programmers have been pumping out for years in a variety of programming languages. You basically take some inputs, you apply some logic, and then spit out something useful in return. It may take other actions as part of computing things, but that's the basic outline of a scalar function. It's going to return a single value. The built-in Transact SQL functions for manipulating strings and dates are examples of scalar functions. A scalar function takes 0 or more parameters and returns a single data value in one of the SQL Server data types. Okay, so let's talk about the syntax for creating a user-defined function. Now, there's a few things to notice about this. First of all, it starts with a create function. That's the usual pattern that SQL Server uses when you're creating a new object. This is going to create a persistent database object. So executing this line of code, or using the syntax, is going to create an object but not execute the code. Just like a stored procedure, you have to invoke the function somehow in order to actually execute the code that you're defining here. All right, so in general, you're going to return some sort of data type, and then the as clause defines the body of the user-defined function. And what you can put in the function is, in the body of the function, is going to depend upon the type of function you're creating. Now, there's a few things in particular I want to note here. So the parameter data type is the data type for an input parameter. And you can use any data type for a parameter except for timestamp. And you can have as many parameters as you want. Well, virtually as many as you want. And then have the returns statement. This is the data type of the output, and it has to represent a single scalar value. But it can be a container, for example, a table type. And then the with function option, you can use that to specify various options in the function definition. And then the begin-end block has to surround the body of the function, which consists of the Transact SQL statements that perform actions and then ultimately compute the return value. The return value of a scalar function can be any of the SQL Server data types except for text, end text, image, cursor, or timestamp. And you just return the value using the return statement. And in fact, a UDF has to have at least one return statement that returns a value to the calling code. But it can have as many return statements as you want so that you can conditionally return different values. Now, I mentioned that there's several with function options. The first one is encryption, which, like stored procedures, encrypts the definition of the function so that users can't easily read it. But just like with stored procedures, this isn't a very strong encryption, and somebody who's really determined and has permissions to read the body of the function is going to be able to do it if they're determined enough. Schema binding, this is similar to views. It prevents dropping the underlying objects used in the function or changing the schema for columns that are referenced by the function. It just makes sure that the function is always in sync with the underlying objects if you use this option. And then there's a couple of interesting options that are specific to functions. Returns null on null input and called on null input. And as you can see, the default is called on null input. So what these options do is that they allow you to improve performance by not invoking the function when one of the input parameters is null. Instead, the function immediately returns null, and that's specifically to returns null on null input. And that can be a huge performance boost if all function parameters have to be non-null values. So rather than running through the code and you have all kinds of conditionals in the code to check for null values and have complicated logic, if you provide null input, it just automatically returns a null. That's a really nice feature in the right circumstances. And then called on null input is the default, which means that the function is invoked even if one of the input parameters is null. So that's the opposite of returns null on null input. And I'll show you an example of that. All right, then the last option is execute as. And this defines the security context when the function executes. What permissions of a principal are going to be applicable when this code executes. All right, so you won't always use these options, but they can refine how the function is defined, which can significantly affect how the function does its work. You can use a simple scalar function that returns a single value to perform calculations and return a value. So here's a simple example. What this function does is it uses data in the Northwind database and calculates the total number of products sold. The return data type is an integer, because I'm just including or returning a count of those products. And then all of the statements that do the work of the user-defined function are contained within the as clause, delimited by begin and end keywords there. Okay, so it just declares a total integer. It assigns the value of the sum of quantity from the order details, and then returns that value. So this is a statement that returns that total value as the value of that function. All right, so this example, of course, is not really wildly useful, but it does show the essential syntax for building a scalar function. In a real application, you'd use a function to calculate something more complex than a simple sum, which you can accomplish more easily by just using an inline function. Okay, but it'll serve for a sample. So what I need to do is I'm going to change to the Northwind database. I have created far too many random objects in the master database, so I'll try to avoid that. And I'll execute the code, which now creates the function, which is now available for use. Now, when you execute the function, you have to use the schema object name syntax. And because it's a function, even though I'm not passing any parameters here, you need to include the open and close parentheses. Okay, I can't execute a user-defined function directly, but I can do that within a select statement. So when I execute this code, we have 51,317 products that have been ordered through various orders in the Northwind database. Now you can use this function anywhere you can use system functions, such as in views and stored procedures, in batches, scripts. So here's an example of using it within a select statement that's actually extracting data from the products table. So I'm calculating the average unit price, returning that as the average price, and then also executing that user-defined function for each row and returning that value as total sold. So it's a regular select statement, but it's returning now two fields, one of which was calculated as the return value of that user-defined function. Now what's interesting about this is that I'm calculating an aggregate here as part of the select statement. Typically, when I include other columns as part of the select statement, I would have to have a group by. But this value here is not a column within the table, so there's no need to include a group by statement here because, again, it's not a column in the table. All right, now, this product sold function would be much more useful if it could accept an optional input parameter for the product ID. So rather than looking at all products, be able to filter things on an individual product. So this next example does exactly that. So it defines a new user-defined function called products sold by product, and it has a parameter called product ID with a default value of null. And the return value is going to be int because, once again, it's going to return a count of the number of products that have been ordered. But in this case, if you supply a product ID, it's going to filter on those products. So what's a little bit different here is that I have this with returns null on null input. So this makes sure that the function is not going to execute if no value is supplied for product ID. In essence, it just immediately returns a null. So the advantage of using this option is that you don't have to test for the default value in the body of the function in order for the function to return null. Because if I didn't include this and I didn't test it, then, and product ID was null, the default value, this is only going to execute on products in the order details table where the product ID is null. And I'm pretty sure that's not null anyplace because this is the order details. It has to be linked to products. Northwind may have some null values in there, but that's not important here. Okay. But so if the value is null, it's not going to execute any of this code. It's just going to immediately return null. So that's a performance enhancement. All right, I'll go ahead and execute that. That creates that user-defined function. And then here are 3 different ways of executing that function. So this first explicitly sends null. So I'm just going to get a null back from this function. You probably aren't going to often explicitly pass null in this kind of context, but you might be passing the value of a variable, and the variable may be null, and maybe inadvertently. And so you'll get a null back from that. The second option uses the default keyword. This just tells the function to use the default value defined in the UDF for that parameter. Okay, so in essence, both of these statements pass a null, and then this statement passes an explicit value for that product ID. So if I execute all 3 of these statements, there are the results. Pass in a null, it immediately returns null. Essentially passed in a null, told it to use the default value, so that returned a null. And then here's the count of products for product ID 3, whatever product that is within the Northwind database. Now, one sort of weird thing about user-defined functions that isn't applicable to stored procedures is that even though I created this UDF with a parameter that has a default value, I can't call the function this way. So it has a parameter, so I need to specify the parameter. And so as I hover over it, you can see the syntax problem here, which IntelliSense picks up on, is that it says an insufficient number of arguments were supplied for the procedure or function product sold by product. Okay? So, and if I execute this, I get the same error message. Okay? So you have to include, if you want to just tell it to use the default value, you have to do that explicitly using this. The problem, of course, is that you don't always know what the default value is. So if you explicitly want a null, if you want to pass a null, you explicitly pass a null value when you call the function.